Hello, everyone, and welcome to our monthly ASQ Inspection Division webinar. Today, we have the pleasure of hearing from Gloria French, and the title of the presentation is the Old 7 Quality 4.0. I wanted to share a little bit of background on Gloria. Gloria is an ASQ Section Leader for the San Antonio section. She holds a variety of certifications. She has developed a passion for quality in products, in process, and in life. She has over 50 years working in the manufacturing industry. She's earned her MBA from the University of Phoenix. Since that time, she has managed the implementation of ISO 9001. She has performed over 250 internal and external audits, developed and certified suppliers, trained and led Lean Six Sigma programs, taught a variety of certification courses for ASQ. She is currently adjunct faculty at continuous education in the advanced manufacturing at Alamo Colleges. And we really do appreciate her spending the time with us today, and we'll go ahead and give her presenter rights so she can go ahead and load up her presentation. Just quick note, after this webinar, you will be receiving your RUs for attending today. And also, I did want to let everyone know that after we'll have maybe 5 to 8 minutes of Q&A, and you'll be able to ask some questions through the chat. So please, we would love your feedback or your questions. So Gloria, whenever you're ready, you can load up your presentation and get started.
Okay, I'm doing that right now. And can everyone, right now, you're only seeing the presenter with my photograph on it, I assume?
Yes, that's what we're seeing right now.
Okay, the other is going to be loading right now. Can you see the screen now?
No, not yet. So you'll have an option to share content, and as soon as you share the content, you share the file.
To share. That's correct.
Yeah.
And let me pull up what I need here and see if I can share it over here. I guess I should have done this while we were waiting.
Yeah, I apologize too. I should have tested that too. So sorry for that.
Okay, now upload a copy to. I don't want to go to OneDrive. I'm sorry, Jer.
It's fine. You could share your screen as well too. There's an option to share your screen if you're having trouble with sharing a file. You can share your screen and then just from there upload it as well.
I just want to be sure they don't see both screens.
Oh, okay. So what you could do, if you want, you can send me the file and then I'll upload it. You want to email me the file and I'll upload it. Sorry to everyone that's attending. We're just having a little bit of technical difficulties with uploading the file. So if you want to send me a copy of it, of the PowerPoint presentation, I could upload it from my end, Gloria.
Okay, it'll be coming momentarily here.
I appreciate everyone's patience. We'll get going as soon as we get this.
Well, I am. Okay, Jared, it's on its way.
Okay.
And while he's doing that, I can speak just a little bit more on my background.
Yeah.
Hello there, everyone. Good afternoon. I just wanted to let all of you know that are inspectors or do the job of inspectors, that I spent several years of my work job as an inspector. I actually started on the shop floor as an assembler. And because of that, one of the positions that I held after about 10 years experience in different assembly positions was inspection. And I've also done auditing, which is a source of inspection. And I've done some documentation reviews, which is another source of inspection. So to let you know, I'm familiar with your job description. And from there, I've learned very much, because I also found that what I remembered most were some of the nonconformities that I found. And that helped me to learn better and faster how to view when I'm inspecting, what to look for, and things of that nature. So I see that he has my PowerPoint up. And the reason that I chose this topic to talk to you about is because Quality 4.0, Quality 4.0 now is always talking about new data, big data. How do we work with big data? A lot of times when you hear people talking about nonconformities now, it'll be the result of data and not exactly inspection. And of course, the advent of the network, internet, all of the modern equipment we have that takes our inspection information and puts it into data have caused this result. So I wanted to go back and remind people about revisiting the old 7, because they are the things that really help us get to the corrective action. So,
Gloria, whenever you're ready, sorry, you could flip the presentation. Just go on the left-hand side, and you have control over it. You could flip through your presentation now.
Is this it?
Yeah.
Right here.
And to the left-hand side, you could go ahead and
this one.
And flip this little buttons on the side that says 1, 2, next page.
Oh, okay. I'm sorry. It is not changing. There we go. No. Okay, so the Quality 4.0, as I was mentioning, blends new technologies with the traditional methods to arrive at new optimums and operational performance, excellence, and innovation. As I mentioned, I believe that the old 7 is what really is going to continue to take us that point where they are blending. The ones that I'm going to discuss today will be cause and effect diagram, the run chart, histogram, flow chart, Pareto, Fishbone, check sheet, and the scatter diagram. Flow charting is one of the first items in setting up a quality system and an inspection. when inspections are created, the engineer or the, the engineer has to set up their process and determine what's going to be inspected and how, and to do that, they use flowcharting. As you can see here, we have one arrow that determines to go out of the box. It also tells us what is the direction of flow. The triangle is decision as based on a question. The question is written inside the diagram. More than one arrow goes out of the diamond because it is a decision. Each one showing the direction the process takes for a given answer to the question. Often the answers are yes or no. This one here is for delivery or wait. We have link to another page. So this little symbol tells the reader that there's more to come. These boxes here are input or output boxes for when we need to add more information. And these two here are the alternate symbols for start and end point. This is a flow chart completed. And as you see, they can get pretty busy. Now, when do I use a flow chart? You may say, when is it really necessary? If you're not sure, even as an inspector, you may want to look at the flow chart to develop an understanding of how the process is done. It is definitely way better if you look at the whole process initially before you do the inspection on a part of it. Because as you know, some of the defects that you see at one station can actually be caused by an element further up the line before you even get it. You may want to study a process for improvement. Maybe that's what you're doing. You want to communicate to others how the process is being done. You could be assisting an auditor, for example. When people that are involved with the process, such as your teammates, operators, they may need an explanation. Sometimes visitors come through or customers, and they have questions. So it's very helpful that you understand the whole process. If you're starting a new one, this always helps to document a process. If the company is expanding or another inspection has to take place, or even if you're going to remove an inspection, that is another time when you want to use the flow chart. Okay, in the flow, materials needed. Sometimes people use sticky notes, cards. They'll use a flip chart or newsprint, marking pens, and then you determine which part of the process, if you're going to just analyze a portion of it or the whole thing. And you will define it and then write its title. At the top, there will be discussions on the boundaries. There will be sequence is going to be very, very important. Brainstorming. Then you will take all of these activities and process items and arrange them in a proper sequence. When they're all included and everyone agrees the sequence is correct, now arrows can be drawn to show the flow. So you will review the flow with others that are involved, and that includes supervisors, suppliers, customers, and workers, to see if they agree that either this is the process that we are doing or this is the process that we are going to do. I hope that most of you can just see the diagram and not all of this other information that's here. But this is the cause and effect diagram, the Fishbone. Okay, it's actually called the Ishikawa Diagram because Mr. Ishikawa developed this quite a while ago, and he uses it for brainstorming sessions. As you can see, we have the most common cause and effects are measurement, material, method, man, which is in the bottom, environment, if I could move it up, it would be helpful. Okay, when are you going to use the Fishbone? Usually you will use the Fishbone during continuous improvement. So even as inspectors or auditors, you would be involved in the process improvement many times after there's been reoccurring defects or nonconformities. And when you're asked to attend a meeting where they're going to analyze this, the Ishikawa Diagram or Fishbone will check out a number of the areas where most of them occur, as I say. For example, in measurement, is it a lab error? Is it an analyst error? Is it a calibration error? Was it a calculation error? If it's liquid, was it contaminated? Was it a supplier issue? Now, if it's materials, we're going to look at issues like raw materials. And where did they come from? From water? Did they come from the city? Did they come from the plant system? Lab, solvent, contamination, supplier, and so on. Method, analytical procedures. They weren't followed. Calibration. Would it be out of calibration, the tools that are used to do the measuring? Sampling. So was our sampling plan good enough? Tooling. And they have an additional assets that are being used to do this analysis. And as you can see, when we look at all of these items, we are trying to brainstorm all of the possible causes of the problem. Why does this happen? This is a good place to ask the 5 whys. As in each idea given, the facilitator in your meeting will normally be the one who is documenting and staging all of the sticky notes or filling in all of the blanks. And he is also that person that's going to continuously keep asking why to get more results and hopefully to get to the bottom of this. Causes can be written in several places if they result in different categories. So this is another one that will be used, especially in continuous improvement. And as an inspector, if you're involved in the corrective action process. And even if you're not, it's always good for inspection or auditors, more inspectors than auditors, to take a look at the line. You're very familiar with it. So you can easily go up the line to find out if the previous operation was okay. You can talk with the operators. Some of them will tell you that they receive it that way. So what do we do about it? Is it currently still occurring? Do we continue to let it happen and do the rework later? Those are questions you could ask yourself. And then also check with your own supervisor to see what they want to do. Now, control charts is another good one because control charts is actually analyzing the results from your Fishbone diagram. It can be if you collect data on those findings. So when do we use it? We want to use a control chart when we're controlling an ongoing process. You visually can see the process changes over time. Data is plotted in time order, and it always has a central line for the average. If you want to do a prediction of long-range outcomes, you can do a control chart. You can compare current data lines. You can draw conclusions about whether the process variation is consistent or if it's unpredictable. When determining whether your quality improvement project should aim to prevent specific problems, you will use a control chart. Most often, control charts are used in mechanical measurements, such as in machine shop. But they also can be used in medical and labs where liquids are measured and very precise. So that is where samples can be taken if you're doing testing. For example, fluid testing, water testing. If you are testing tensile strength, for example. If you're even checking the results of a test that was done on software, how many bugs were shown during that test, and how often did they occur? They should occur 100% of the time, but there are some bugs that relate to mechanical operations that are not that consistent. And this is where you could find out about the consistency. So when we make a control chart, we want to choose the problem or event that we want to do it on. Decide when the data will be collected. As with control charts, time and temperature are very important. The reason being, if you take it after lunch, for example, one day, and the machine had a chance to set during the lunch period, you may have different data than if you took it just before lunch when the machine's been running for hours. So if you're going to do controlled samples, you definitely want to control the time that they're going to be taken, and you want to control the environment where they're going to be taken. If you're already in an environment that it fluctuates, for example, then you're going to have to determine that is going to be part of your sample. So you could randomize when you take the sample based on the fact that your environment changes. Only that would be part of your data that you would collect. we want to label all the spaces on the form. So when we design the form, as the example shows here, we will use all of the lines. They're all identified on both sides. This has upper control and lower control limits, and it also has time. And that'll be the situation with most charts, but not necessarily. We will test the check sheet for a short trial period to be sure it collects the appropriate data. It is easy to use. Each time the targeted event or problem occurs, record the data on the check sheet. And we will see the check sheet coming up here shortly. With the histogram. It's a frequency distribution, and it shows how often each different value in a set of data occurs. It's most commonly used to graph to show frequency distribution, such as if you're in logistics and you want to track when do most of your trucks arrive. And this may not even be an inspector. This could be someone working on the dock, and they're recording what time the trucks come in. Also, it could be related to what time certain suppliers get there, if you happen to have a daily delivery. When you want to see the shape of the data's distribution, especially when determining whether the output of the process distributed normally. So the data does have to be numerical. When analyzing, we'll also use it when analyzing whether a process can meet the customer's requirements. So for our suppliers, we are the customer. Are they meeting our requirements? When analyzing what the output from a supplier's process looks like. So this would probably be around your incoming inspection. We want to know from our perspective how are our suppliers doing. When seeing whether a process change has occurred from one time period to another, this will definitely give us the information. Sometimes companies frown on collecting all of this data, but now with the internet and with all of the tools that we have, such as barcoding, we can just swipe barcodes and that information will go into a database that we can take a look at later, which is part of the Quality 4.0. In the past, a receiving inspector would have to manually log all of this data. If we want to find out if the process change has occurred from one period to another, when determining whether the outputs of two or more processes are different, and when you want to communicate distribution of the data. So we need to send this report to our management or to the company that may do the trucking. And it's a lot easier for them to understand a histogram analysis than for us to just give them the numbers. Here's the check sheet. When do we want to use a check sheet? When data can be observed and collected repeatedly by the same person or at the same location. when collecting data on the frequency or patterns of the events, problems, defects, defect locations, and defect causes, etc. When collecting data from a production process. A lot of times, for those who are familiar with the X-bar R charts and data on machining processes, the check sheet is included at the bottom of the graph so that it makes it easier. The calculations can be done right away and they can be graphed. Check sheet procedure. Decide what event or problem will be observed. Develop operational definitions. Decide when the data will be collected and how long. How many times a day, for example. Design the form. Set it up so the data can be recorded simply by making check marks or X's or tick marks so that you do not have to be recopied for analysis. Label all the spaces on the form. Test the check sheet for a short trial period to make sure that it collects the appropriate data and is easy to use for the person collecting the data, which is usually an operator or a worker. Each time the target event or problem occurs, record the data on the check sheet. Pareto diagram, another one of my favorites. And, well, we'll get into it. I'll tell you as I go through. We will use the Pareto. It's a bar graph. The length of the bars represent the frequency or the cost, time or money, and are arranged with the longest bars on the left and the shortest on the right. In this way, the chart visually depicts which situations are more significant. We would use it when we're analyzing data about the frequency of problems or a cause. So we're defining them. When there are many problems or causes, and you want to focus on the most significant. When analyzing broad causes by looking at their specific components, or when communicating with others about your data. So the Pareto is visually effective when sent out to the necessary parties, and I believe that everyone likes the Pareto and uses it frequently, and they may even arrive at the information after doing a Fishbone diagram. All of these intertwine with one another. One by itself will report the information, but it will not resolve it. It will contribute to it. Pareto chart procedure. Decide which categories you want to group. Sometimes there's more than you want, and they can be combined if they're significant enough. Decide what measurement is appropriate. Common measurements are frequency, quality, cost, and time. Decide what period of time the chart will cover. 1 work cycle, 1 full day, or a week. Collect the data, recording the category each time, or assembly data that already exists. Subtotal the measurements of each category. Determine the appropriate scale for the measurement that you've collected. The maximum value will be the largest subtotal. And thank goodness for Excel, because Excel will do this for you in its charting process. Construct and label bars for each category. Place the tallest at the far left, and then the next tallest to its right, and so on. So many of you can see an advantage here and may have even used it. A scatter diagram. The scatter diagram is another way to plot the data that you have collected, especially if it seems very random, like information from a control chart. Some people will compare a control chart data with a scatter diagram just to check out and see about its linearity. When you use a scatter diagram, you want to have paired numerical data. When your dependent variable may have multiple values for each value of your independent variable. When trying to determine whether the two variables are related. For example, when trying to identify a potential root cause of a problem, after brainstorming cause and effects using a fishbone diagram to determine objectively when a particular cause or effect are related. When determining whether the two effects that appear to be related both occur in the same cause. When testing for autocorrelation before constructing a control chart. So to do a scatter diagram, we collect pairs of data where a relationship is suspected. For example, as we were discussing earlier, if we were taking data on a machine and we have an environment around us that is not controlled, that would be an excellent time to use a scatter diagram. When you are measuring your environment, either by temperature, humidity, or whatever needs to be measured, and the results that you are receiving from your manufacturing process. We will draw a graph with the independent variable on a horizontal axis and the dependent variable on a vertical axis. For each pair of data, we put a dot or a symbol where the axis value intersects the y-axis. If the two dots fall together, put them side by side so that you can see them both. When we've done this, we will then look at the pattern of the points to see if there is a relationship. Is it obvious? Does it look like a line or a curve? If it does, then you have your answer. You would stop there. The variables are correlated. And then you could further by using a regression or correlation analysis to complete the following steps. Here's the process. We collect the pairs of data where the relationship is suspected. We have the data in front of us. Then we'll draw a graph with the independent variable on the horizontal and the dependable on the vertical. For each pair, we're going to follow the process that was explained. Then we're going to divide the points on the graph into 4 quadrants. If there are X points on the graph, count the X plus 2 points from the top to the bottom and draw a horizontal line. And then count the same points from left to right on the vertical line. If the number of points is odd, draw the line through the middle point. Then count the points in each quadrant. Do not count points on a line. Add the diagonally opposite quadrant and find a similar sum in the total of all the points in all the quadrants. This next slide will show you an example. So this manufacturing team suspects a relationship between product purity and the amount of iron measured in parts per million. So, excuse me. So they, excuse me just a minute. Okay, purity and iron are plotted against each other as a scatter diagram is shown. There's 24 data points. Median lines are drawn so that 12 fall on each side. To test for a relationship, then they do a calculation. The number of A points in the upper left quadrant plus the points in the lower right quadrant equals 18. If everyone can see that. So B, points in the upper right and points in the upper left equals 6. You can see there's 3 points in each quadrant. Q, the smaller of A and B, equals the smaller of 18 and 6, which equals 6. Now N, which is the number, equals A plus B equals 18 plus 6. So there's a total of 24. Then they look up the limit for N on the trend test table. For N is 24 and the limit is 6. Q is the equal of the limit. Therefore, the pattern could have occurred from random chance, and there's no relationship. And no relationship is being demonstrated. Now, of course, there are considerations for scatter diagrams. So we want to look at the relationship between the variables. Think creatively when you're doing a scatter diagram and use it to discover a root cause. If there is no relationship, consider whether the independent variable has widely varied. Sometimes the relationship is not apparent because the data didn't cover a wide enough range. This information will be available for you if you can request it either from myself or from jail. I'm sure that you'll be able to get a copy to continue through this process if you would like. Are there any questions?
Thank you, Gloria, for a wonderful presentation. We really do appreciate it from everyone here at the Inspection Division. If anybody does have any questions, please use the chat. I know some comments did come in earlier, but there were more comments than questions. So if you do have any questions that you would like to get answered, please feel free to send them through. And like I said at the beginning of the presentation, you will be receiving your RUs 24 hours from this presentation. And like I mentioned, Gloria, we do appreciate your time and you sharing your knowledge and expertise with our members. And if anybody does want a copy of the presentation, Gloria has given permission to just send us an email, and we'll go ahead and send you a copy of the presentation. We'll give it a couple minutes, see if any questions do pop up. If not, then I just want to let everyone know that next month we'll be having our December webinar, and that's the last one for the year. And I want to thank everyone that attends. We do appreciate your presence, and we do want to continue doing this. So we might send a survey at the end of the year to our members just to see, get some feedback of what kind of topics everyone would be interested in, or what is it, some of the stuff that's out there that you all want to hear. So just be on the lookout for that. Let's see if anything pops up here.
Jer?
Yes?
I wanted to mention to everyone that this information, even though we've all seen it through training, came out of the QP Quality Progress magazine. And I am hoping that people that are members really get a chance to at least glance through that magazine when they have it. There is a lot of talks these days about Quality 4.0, and it goes along with Manufacturing 4.0 that is being changed. We are seeing numerous changes in how we collect our data, who is collecting it, the type of training necessary to go along with the changes in manufacturing, which is instrumentation, robotics, the data collecting process, which is why they talk about big data now. They still are looking at teammates and operators to collect the data to be part of the quality. But in the end, all that data will be uploaded into something significantly larger that can be shared with customers, for example, and suppliers when necessary.
Okay, yeah, I think that's a little bit of kind of ties it with a question we did have, because one of the attendees wanted to know where's the connection to 4.0. So I think you kind of gave a little briefing, like it's more of like this is the collection methods that we've been using for a long time, right, that have been around. But now these data methods are being connected to the data that's now being managed and configured and analyzed, right? Is that the connection?
That's the connection. And in some cases, they're going, instead of a person collecting the data, machines are going to do it. Machines are going to inspect. Machines are going to barcode. Barcode is on everything now, so a lot of the data won't require people to collect it. Now, people will still be involved in parts of the corrective action, and that is also why I wanted to go back through these. But they're coming up with, because it's data that they have, they're coming up with new ways, new analysis techniques. And I would suggest keeping an eye on the Quality magazine for more information, because almost every month there's a little bit on that topic in there and how it affects the system as a whole.
Okay, well, thanks a lot for your time. Like I mentioned again, thanks everyone for attending. We look forward to having you next month for our final end of the year webinar. And everyone have a great rest of your days, okay? And Gloria, do you want to close out with anything?
I want to thank everyone for tuning into this webinar. I know that probably all of you are already familiar with these practices, but some people and some companies have already gotten away from them. And that is why I chose this as a topic, because these work on even on a grand scale. So I hope that this is a reminder to you. So if you get into a situation where you need to collect data, there are many different ways to do it, how to share the data, and which data analysis would be the best for your application. Okay?
Have a good day.